The rest of this video is going to show you the definitions of all of these things that are listed on this slide. You can skip around, fast forward, pause, rewind, whatever you need to so that you know what each of these terms mean. An undefined term in geometry are the most basic figures in geometry. And they're called undefined because they cannot be determined, or they cannot be defined by using other figures. And the undefined terms that we're going to be using are going to be point, line, and plane. We will be defining these, just not with other figures. One of our undefined terms is a point, and a point is a specific location. It has no dimension though. And it's represented by a dot. And often with a letter identifying it, this would be called point P. Line is the next undefined term, and a line is a connected path. Let's identify that. It's a straight path and is connected by points, or it has no thickness, and it continues forever in both directions. So we could draw this, it would look something like this. We could name this in a couple different ways. We could call this line L, or line AB, or even line BA, or we have a designation symbol that's also line AB. We could also do it line BA. Then we come to a plane, another undefined term. A plane is a flat surface and it has no thickness, and extends forever. And we can draw that kind of like this. It looks like a parallelogram. And we can put some points on it. J, K, L. And we can call that plane M if we want to. A script capital letter, that would be this, or 3 points on the line, J, K, and L, you could use to name this. We could call it plane M or plane JKL. The term collinear refers to lines that are on the same line, or points that are on the same line. Points So if I have a line and I have some points on here, K, L, and M, K, L, and M are collinear. If I have a point off of this, N is non-collinear. Coplanar, also talking about points, it could also be lines. These are going to be points or lines. That lie on the same plane. So if I have a plane and I have a line on that plane and a point B, I could say that point B and line L are coplanar. If I have a line out here, this would be non-coplanar. We have a line segment. That means that is a portion of the line. Remember, lines go on forever and ever. Consisting of 2 points. And all the points between them. So we would draw it with a point and a line to another point. We could call this line segment CD, and we would put a little line above it without arrows to call that line segment CD. An endpoint is a point. Endpoint is a point at one end of a segment, like the line segment that we just learned about, or it's the starting point of a ray. And we designate these by a capital letter. Such as C, D. So C and D are endpoints of the line segment CD. A ray is a part of a line. That starts at an endpoint. and extends forever in one direction. So we'll have an endpoint, let's call it R. And it's going to continue on and on forever. We want to know it goes through another point so we can name it. This would be ray RS, and our designation would have the arrow over the S because it continues through and through that. If I wanted to go the other way, I would name this one SR, always starting with that endpoint. Opposite rays. These are two rays that have a common endpoint and form a line. So if I have line here and I have 3 points, F, E, and G. The opposite rays would be EF and EG. Those are opposite rays. We're going to be looking at a lot of postulates in this class, so we should know what a postulate is. So a postulate, and if you are consulting other videos or textbooks, you could hear this called axiom. Our textbook is going to use the word postulate. It's a statement that is accepted as truth but we accept that as truth or as true without proof. These postulates about our points, lines, and planes are going to help describe our geometric properties that we're going to be learning. A line postulate, once again, something we accept as truth without proof, is that through any 2 points, there's exactly one line. So I have a point here and a point here. I can only draw one line. Oops, I missed my point. 1 point. I can only draw one line through those 2 points. Our plane postulate states that through any 3 non-collinear, so these have to be not in the same line, points so these points that are not on the same line, there is exactly one plane. Containing them. So if I have 3 points, I can only have one plane that touches all three of those points, as long as those points are not collinear. And then we have a postulate about a line and a plane that states if 2 points lie in a plane, and we know from the line postulate that only one line can go through those 2 points, we're going to state that the line containing those points lies in the plane. So we've got a plane. If these 2 points are in that plane, then the line that connects them is also in that plane. We also have a postulate for when lines intersect, where they cross. So, if 2 lines intersect, remember that means they cross each other, then they intersect in exactly one line, in one point. So I've got a line here, and I've got a line here. Their intersection is just 1 point. And our planes can also intersect, so we have a planar intersection postulate, which states if 2 planes intersect, then they intersect in exactly one line. So we have 2 planes that are intersecting, and this line is its intersection.